So here we start our fourth dimensions slideshow, and this is our final show for this topic. Um, this is a base plate of some sort, and the emphasis here is on drawing circular objects, both that are drilled through the body of a object, and also cylinders that project outward from the surface. And we just want to clarify how you dimension round things like this. You have to remember everything that's circular has to be located for its center point somehow, and then also given the size of the arc or the circle. In the case of cylinders, you have to give the height of the cylinder. But the most important thing is that hole sizes and locations are shown, and cylinder sizes and depth are completely dimensioned. You can insert a center mark in AutoCAD using our standard center mark tool, and then explode it, remove all of the extensions on it, and just be left with this nice little center mark that makes a good basis for annotation. So you might consider that if you think that works for your drawing. Some types of rounded surfaces don't require the center mark. We've seen this going on with some of our drawings where we have fillets. We just call them out with their radii. And the reason why we can do that is because we're generally assuming that they're tangent to the lines that they run into. And so if someone wanted to, they could determine the actual arc length and other values associated with the arc just by doing the geometry between the tangent lines. In our case, we don't break it down that far. We're just worried about annotating them. And so in this case, you would just put in your radial. Here's your pretend center point, though, that it's pointed at. You know, that hasn't changed. And then it's radial out. It's got a little landing, a gap, and then it's got your note on there that tells the reader what's going on with that rounded feature. We'll be looking at different kinds of drilled holes. If the hole doesn't go all the way through the body of the object, then it's blind, and or as it's called, and the holes generally where they show up as round is where you put the diameter on them, and it's also where you would locate the center point. But then on the profile view, similar to a cylinder, we would show the depth. And the depth for holes like this is the from the surface to the end of the full width of the hole. These little tapered ends are, let's just say, hardware dependent or drill dependent. This is the main thing that we're dimensioning. Counterbores have their own symbology. You'll get used to it at first, but it looks sort of like this. The first bit of information is about the through hole. So it's saying that the diameter of this part is 10, because that's the part that initially they would have drilled with one drill all the way through here to make that drilled opening. Then they come back with a different drill, or sometimes it's a two-part drill now that everything's so fancy, but in the olden days, there would have been a separate tool that would have been applied to this that would have had a stop on it so it didn't overbore this part, this depth, and then created a little wider pocket. And then that part of the work is where the nut goes. And so it has to be sized, you know, if your nut head is in here, it has to be sized so that you could get a socket wrench inside that counterbore. So counterbores are designed actually very specifically for the type of hardware that goes into them. And so this drill down bit is the exact distance that this wider pocket is recessed in, and the symbology for the counterbore is this U sort of shape, and the diameter then is this diameter. This first diameter is for the through hole. So this is 10 going through and 20 for the pocket for the counterbore. And then countersinks are very similar. They're different shape. They have a little different symbology. This is for hardware where you have an angled head on it. It could be a machine screw or wood screw, but it's got that little beveled top on it. And these are usually slightly recessed so that nothing catches on them, and that's why they're actually set this way, so that it's a very smooth finish over the top of the head of the screw. And then in this case, it's a blind hole. And so the symbology over here is that you have a diameter 10, and it's pointing to the outer edge of the countersunk hole. But what this is saying is that the diameter of this blind hole, the narrower hole, is 10. The drill depth, so the full height from the surface to the end of that depth is 30. And then it has a countersunk top. That's a symbol. You get that off your GDT keyboard. Diameter 20. And that would be here, the diameter 20. And the angle that this line would make with this line is 90 degrees. That's how it's defined. So if this line was moved, if you cut and paste this little line right here over to here, and then you cut and paste this little line over to here, right? You'd have this sort of V right here. That angle would be the 90 degrees. And that's how you're going to have to figure out how to draw these, because you have to say, okay, I know the angle. Now I have to move it over to where it is applied. So that's a little tricky to draw. And luckily, AutoCAD kind of mimics this information on chamfer. You'll remember when we did our chamfer command that we had two ways to do it. We could put in a distance and a distance, which would be this little distance and this little distance, or we could put in one distance and an angle. And chamfers that's how chamfers are defined in general in both construction trades and machining. So AutoCAD is consistent with that. But when you're annotating it, this is 2, so that's the distance here, by 45, the angle. Or I could have gone 2 and 2. This one, it's 3 and 45. So the last little thing here is notes. You will come into notes, and generally some of the sort of most important things that you want your reader to appreciate are put up in notes, and often quite bold, and usually with a big label on it, note. And sometimes I put in my reference standards here too. They talk about manufacturing requirements, but for me as a civil engineer, manufacturing requirements might be, all work shall comply with the current building code, something like that. Details on treatments and finishes, blanket dimensions, so things that are sort of universal throughout the project that the reader might want to know. And for home plans and for things of that nature, you might also be putting in permit requirements, like contractor can't work before 8 o'clock in the morning because it's a quiet residential area. Anyway, that's it for our dimensioning annotation presentations, and good luck with your drawings, and thank you for your attention.